All right. Emma bought a high bounce ball from a company that claims that with each bounce, the ball bounces up to a height that's 75% of the original height. She sets up a tape measure, drops the ball, and lets it bounce 3 times, and her data is charted below. Emma wants to find the sum of the heights after 10 bounces. What's the sum of the heights rounded to the nearest hundredth? So that means that we're going to continue this all the way down to 10, right? And we want to know, we're going to fill all these in, and we want to know what the sum of all those heights are going to be. So it tells us the common ratio. It tells us that each time the height is going to be 75% of the original height, and that really should say the previous height. So each time it bounces up, it's going to be 75% of the height that it was in the bounce previous to that. So that means from here to here, we multiply by 0.75. From here to here, same thing, multiply by 0.75. So that's our common ratio. We're just putting the percent in decimal form. Then we have our first term, right? Our first term is 4. That's our first height. And then it says she wants to find the sum of the heights after 10 bounces. So 10 is going to be our n. We don't have the last term of this sequence, so we're going to use that first formula, the one that looks like this. We're going to do S of 10 is equal to the first term minus the first term times r to the 10th all over 1 minus r. So I plugged in n already. Let's plug in a1 and plug in r. So I have 4 minus 4 times r, which is 0.75, raised to the 10th power, all over 1 minus 0.75. And back to my calculator, 0.75 raised to the 10th is a really long decimal. So I'm going to, let's see, it says to round to the nearest hundredth, but I'm not going to round to the nearest hundredth till the end. So I'm going to round to the nearest thousandth for now. So I would have 4 minus 4 times 0.0563 all over 0.25. And now I'm going to do that last part of the problem. 4 minus 4 times 0.0563 equals divided by, and I got approximately 3.7748. Actually, not approximately, that's exactly what I got because I rounded. And I'm running out of room. Let me write it down here. And I'm going to divide that by 0.25. And I get 15.0992. So if I'm rounding that to the nearest hundredth, then it would be about 15.10, right? Because this 9 would make this 9 round up. So 15 and 10 hundredths, or 15 and 1/10. But it did say nearest hundredth, so you should include that last 0. All right, that's our final answer for this one. Let's look at one more. The diameter of a bacteria colony that triples every hour is represented by the graph. What's the diameter of the bacteria after 7 hours? So I'm going to take these points and put them in a table. So this is my time, and this is my diameter. After 1 hour, the diameter is 3. I got that from this point here. After 2 hours, the diameter is 9. After 3 hours, the diameter is 27. And it tells us the common ratio because it says that it triples every hour, but we can also see that in our chart, in our table. So our common ratio is 3. And our first term is also 3, right? Because after that first hour, the diameter is 3, so that means that our first term is 3. And then the number that we're looking for is after 7 hours, so n is 7. I have the first term, the common ratio, and the n, so I'm going to use that first formula because I don't have the last term. And that formula looks like this. And I'm going to plug everything in. So the sum of the first 7 numbers in this sequence would be A1, which is 3, minus A1 again, which is 3, times R, which is also 3, raised to the nth power, which in this case is 7, over 1 minus 3. So let me figure out 3 to the 7th. That's going to be a pretty big number. 3 to the 7th power is 2,187. So I have 3 minus 3 times 2,187, all over negative 2. And now I'm going to do the top. 3 minus 3 times 2187 equals, and I got negative 6,558 over negative 2. And I'm going to put that over here. Divide that by negative 2. And I get 3,279. So that is the diameter. And it didn't really tell us what units, so maybe millimeters, I would guess. And that's it.